All right, so for our second example this morning, we're going to find the area again first. We're going to do it with and without technology. And then what we're going to do is find the volume of the solid of revolution. And yeah, Mr. Isaac did the same thing. I forgot to make the grid right. Oh no. Okay, I'm going to put a sample point here. I'm going to do my best to make it look like a vertical line segment to the axes. You can see I will be integrating in X. My height, when I look at this ordered pair, is Y. So the area of my slice is going to be Y times little dx. Now sometimes I draw actually slices in there, but I just didn't. 9 minus x squared is Y in X. Now, if you go through this process, you can easily see that your integral will be set up. Okay. Now, I will go from 0 to 3 in X. I could have done this one in Y, but it's just easier to do it because then I have less work to do. Well, actually, no, I don't. I lied. I'll do it in Y below. So this will be 9x minus 1/3 x cubed evaluated from 0 to 3. And then this will be, okay, 3 times 9 is 27, minus 27/3, I hope is still 9, minus 0, which is 16 square units. Okay. Now, if instead I would have drawn the sample point this way, horizontally, well, we know y is equal to 9 minus x squared. Hold that in your memory bank for a second. You'd be integrating in y. So x would be your height. Or if you really want to think about it, let's say it's your base, your height would be dy if you want to say it that way. So I need to solve this for x. And I know I need the positive branch, so I can do that. So first thing I'm going to do is add x squared to both sides, subtract y, and take the square root. So 9 minus y in y, but be careful because see now y goes from 0 to 9, and I'll leave it to the reader to show that that's 16 square units. But let's pull up our calculadora. I've already set up this parabola. I would like to just focus on analyzing the graph through the integral from 0. Now, when you're on this screen, you can only do it in terms of x. Whoa. Oh, you know what? I subtracted wrong. 27 minus 9 isn't 16, it's 18. Mr. Isaac made a subtraction mistake. Let's go fix it. So it's 18 square units. But now let's do this though. The Inspire can do this. Menu. We're in calculus class. Excuse me, my sinuses are like wanting to blow up today. I'm going to go from 0 to, oh, not 9. There. I want 9 there. And I want the square root of 9 minus y. Now this antiderivative, if you think about it, you're going to gain a power. So it's going to be minus 2/3. The quantity 9 minus y to the 3/2 evaluated from 0 to 9. Okay. Let's see if I'm doing this correct in my head today. Times 9 minus y to the 3/2. Get outside. Control equals to get the such that bar. Now we already know it's 0. That's 0 because I can't. Oh, my sinuses. And then, excuse me. Then this bottom one is going to be negative 18, right? But since I'm subtracting it, it becomes positive. And then, notice I did this in my head, minus, same answer. Okay. Now, Mr. Isaac made a mistake when he did this. I didn't give you enough to do this for revolving, so let's do this now. It won't be as great. I'm going to put my sample point there, drop, and actually I could do this in Y, but that would be shells, and we haven't done shells. Okay, graph the reflected area, just try to make it look reasonable. Yeah, I know I have a bunch of young adults that want everything to be perfect, but you can't always make it perfect. Draw on a few more revolved slices so you can see the illusion of a cross section. I'm going to bring this out, and you can see that I have this little disc. In this case, the height is in dx, the radius will be y, so the area of the cross section will be pi y squared dx. But what is x? Okay, which is pi x squared minus 9 squared in x. But when I write this, look, I can't integrate this the way it is. So what I'm going to do is multiply that out. That's x to the 4th minus 18x squared plus 81 in x. We're going to go from 0 to 3. So this is pi. Okay, this is 1/5 x to the 5th minus 6x cubed plus 81x from nothing to 3. Okay, well, this is pi. Okay, let's get ready for some ugly things here. Let's see, 3 to the 4th is 81, so that's 243/5 minus 50. Okay, that's 27. 27 times 6 is 120 and 42. 120, 162, and this is 243. Now someone check my arithmetic. I could have multiplied that wrong, but we're going to have a bunch of zeros here, right? Okay. And 243 minus 162 is 1, okay, 14 is 8, 81, okay. So this is pi times 243/5. Now 80, wait, there, not minus, plus 81, excuse me. So that'd be 405/5. Let's see if I added right. I could have made an arithmetic mistake, folks. We'll check that in a second. That would be 5ths, 8, 4, 6, 48/5 cubic units. If I added right, but let's find out. Okay, let's do this first. So I'm going to do pi, and then I'm going to do 9 minus x squared. That's kind of ugly. Notice at 3 it's a 0. Okay, let's think about that. At 0, this would be about 30. Okay, so we'll do 30. Boom. That's good. That's good. And now, let me clean up this. I just like to clean things up. I know I probably shouldn't. -1 to 4, count by 1s. -2 to 30, we'll count by 5s. That looks so much better. Menu, analyze the graph, integral, 0, 3. Okay, hold on. Okay. That's probably exact. It's probably exact. Okay. Now, let's do something a little bit different here. Okay. When you're dealing with the Inspire, if you do not put let's square it. If you do not put, anything, will give you the antiderivative, but notice it doesn't give you the constant. Now, I don't know if I copy, see if I copy it, it won't. Let's do this. Control, copy. Okay. Integral. We were going to 3, right? Okay. I guess I did do the arithmetic right in my head. Alright, now as you can see, these take time, and then when I go to show you with the technology, it just takes me more time.